Hi, everyone. Good to have you here with us. I feel that our industry is at a very key inflection point where it's going to grow well beyond cryptocurrencies and into the real world. By growing into the real world, it will redefine our industry from something that is about meme coins and things that are not backed by real value into how the world works, into how all value is formed, how all ownership is defined, and how all transactions are managed. This is the world that our industry has been working towards over time. And I think a lot of the speculative activity and other activity has basically been a short interim stage, just like at certain points in the internet's early development. One of the only things that you could say about it was that it would replace the post office. But as we all know, we have now gone very far past replacing snail mail in the internet to actually having it power very large parts of our lives. The economic part of our lives, though, is still managed in a way that's suboptimal, that has all kinds of risks, all kinds of failure modes, all kinds of counterparty risk problems, and all kinds of other limitations. These are the limitations in our economic life that I think our industry really focuses on. And it's hard sometimes to understand because those limitations need to be addressed by solving what are known as back-end problems. So not problems that immediately affect the consumer by building a new application, but problems on the back end in the background, things like the infrastructure of how the system works. So this is how I encourage you to think about our industry, that it's both at a key inflection point where it's going to change what it's about, and that it's about creating a basic set of infrastructure pieces that are then turned into user experiences through various banks, fintechs, DeFi protocols, and so on. Now, the numbers tell a very clear story about our industry, and that story has two key points. The first point is that it's very early. Our industry is still very early in its development. And if you look at all the value that can be placed on chain across all the different types of financial products, insurance, global trade, derivatives, commodities, all of these things will eventually be on chain. But the percentage of them that is on chain right now is well below 1%. It's an extremely small percentage. And so even if 10% of all of these assets goes on chain, our industry will evolve from something that's in the neighborhood of 2 to 4 trillion to tens of trillions. And this is that redefining event about how our industry is going to change that I mentioned before. Our industry at some point will be more about real world assets than it is about cryptocurrencies. Cryptocurrencies will be a subset of what blockchain technology is used for. But my belief is that DeFi and real world assets will go on to grow far beyond the value of just cryptocurrencies. My personal view is that over the next few years, we're going to be seeing a massive rate of adoption across banks, asset managers, even central banks, CSDs, and some of the large financial infrastructures of blockchain technology. That will create the infrastructure that allows great user experiences to come into existence, sometimes generated by those banks, sometimes generated by fintechs, and sometimes generated by DeFi public chain type companies. All of this will result in the migration really of all value and all digital relationships into an on-chain state. This basically means that all of our digital relationships, all of our value, all of our assets, all of our transactions will be somehow secured by a blockchain, similarly to how today they are secured in databases. And the fundamental reason for this is that blockchains are a more reliable, more secure, also cheaper and faster way to secure those relationships and that value. So this is now the path that we're very clearly on in both the public chain world and the private chain world. Now, to do that, there are a number of problems that still need to be solved around scalability, privacy, and the ability to have everything connected so that many different chains and many different pieces of data can all work together to make more advanced user experiences around various financial products, transactions, digital relationships, and so on. These transactions, value, and digital relationships will go from everything as simple as gaming to everything as complex as central bank digital currency transfers. And frankly, the economics of entire countries will be based on this system as the technical backbone. The system I'm describing is really a combination of blockchains as data structures, smart contracts as small pieces of logic that are very secure and highly reliable, and Oracle networks as the systems around the blockchains and smart contracts that are doing all the additional processing, all the additional connectivity, some of the scalability, and some of the privacy that guarantees more security, more features, and more kind of capabilities to make more advanced use cases. Now let's look at the problems that need to be solved in order for all of this to happen. The first problem that needs to be solved is the ability to inject critical data into applications. This is the first problem that the Chainlink community worked on and successfully solved by allowing data to flow into blockchains. Blockchains are limited by something known as the Oracle problem. The Oracle problem is where you basically cannot connect blockchains to any other system, a data system, a payment system, an AI system, another blockchain. They can't really be connected to anything. And if you're going to connect them to something, that thing gains control over the blockchain, over the smart contracts. So the first problem was, how do you successfully get data to connect to smart contract applications? The second problem was, how do you do the computations that blockchains are not able to do? So there are many computations that blockchains can't do. How do you do those additional computations in a safe and reliable way? And then the third problem was, how do you connect all of the different blockchains and all the different smart contracts on the different chains into a single interconnected set of applications? This third problem is often known as the cross-chain connectivity or interoperability problem. Now, all three of these problems are solved by what the Chainlink community invented and originated, which is Oracle networks. Oracle networks are basically what allow all of these external events to happen in a reliable way. Historically, what you would have done is you would have connected one server to another server, and then the control is ceded to those servers and the people that control those. In the Oracle network world, you have a set of servers, a set of nodes that come to consensus and generate agreement on external things, just like blockchains generate agreement about blocks and transactions. The critical thing about Oracle networks is that they're able to generate agreement and consensus and guarantees about things that are outside of a chain. Connectivity and use of AI models, various data, various key computations, and even connection and use of other blockchains and other smart contracts, because blockchains and smart contracts cannot exist on multiple chains without an Oracle network connecting them. So this is what the Chainlink network does, and this is what the Chainlink community works on. It's the set of infrastructures and the set of protocols that allow all of this different data, all of this different computation, and all of this cross-chain connectivity to come together and create more advanced user experiences and smart contracts that define the future of the blockchain industry. Chainlink has been initially known for allowing the DeFi boom to happen, where Chainlink powers the majority of DeFi today and has powered the majority of it throughout the life of the industry, from back when the industry was below 100 million to now where it has passed 200 billion in recent years and fluctuates between 1 to 200 billion now. The key thing to keep in mind about Oracle networks is that they're a completely unique way to generate consensus that is not about making blocks. It's not about making blockchain transactions. It's about verifying and validating everything about the external world, everything that needs to be connected, everything about AI models, everything about using other chains, and allowing all of those things to interact with blockchains and smart contracts in a useful way. So in the case of data, this is about aggregating data. In the case of off-chain computations, it's about multiple nodes generating a computation in a similar way to a blockchain, but not making its own block, injecting that information into the block of many different chains for many different use cases. And for cross-chain, it's about validating the different pieces of data and value moving across chains. For AI models, the use of an Oracle network are things like querying multiple AI models, coming to consensus about the result, and therefore minimizing the risk that maybe one of the AI models was inaccurate or false or didn't have a good result. And this is what Oracle networks do. They don't just create connections, they create validation to make sure that the thing you're connected to operates correctly. Now let's look at how this looks in the real world asset world. In the real world asset world, the first thing you will need to do is inject various pieces of data into a real world asset. You'll need to provide price data, identity data, reference data, NAV data, all kinds of data in order for the asset to even come into existence, because it's a real world asset. It's tied back to something in the real world, some kind of underlying asset. And that connection back to the underlying asset happens through the Chainlink set of Oracle networks and protocols. The next thing that you're going to do after you generate a reliable real world asset that's correctly and successfully connected to data is you're going to need to move it across chains. As you move it across chains, you're going to run into the problem of fragmented liquidity. There's going to be liquidity, purchasing power, stable coins, user accounts on hundreds of chains. These hundreds of chains have users and purchasing power and liquidity that wants to acquire your real world asset, but it is unable to acquire it just by virtue of being on that other chain. So now you have to solve this problem of interoperability. This raises the question of how do you solve the problem of interoperability while keeping data in sync with the asset, right? Because the first thing that we did was we generated an asset that is synchronized with data. And by being synchronized with data, it acquires its unique properties of what we call being a unified golden record. The unique properties around making sure that key pieces of data are attached to the token so that you don't just have an ownership right, you have an ownership right with key pieces of data that prove things about the underlying asset. And those key pieces of data continue to be updated and in sync with the real world. And therefore, you do not need to go and seek all the data. In the old model, the data would be somewhere else and the ownership right would be somewhere else. Now, in this model, the ownership right and the data are all in a smart contract. And that smart contract is a container for the ownership right and the data. And the data is continually updated so that anyone who wants to purchase the ownership right, wants to regulate it, wants to understand it, wants to see what they want to do with it from a risk point of view, has that data right in that container. That's one of the big powers of smart contracts that we're all trying to achieve here, is the creation of these unified golden records. But the problem starts to become, if I'm going to send my unified golden record to another chain, how do those data connections persist? How do they continue to gain access to the data? Because the data is dynamic. The data is always changing. There are always updates to the price, updates to different parts of the valuation, updates to even identity requirements. All kinds of updates have to happen. The more complicated the asset is, frankly, the more updates need to happen. And the more regulated it is, the more updates need to happen. So the problem isn't just about generating the unified golden record on one chain, and it isn't just about moving it across chains. It's about doing that in a way where the unified golden record remains connected and synchronized with data. And because the Chainlink platform and the Chainlink community are the only group of people that make both a data standard and a cross-chain connectivity standard, naturally, we've done it in a way where the data and the value become tightly coupled. They become connected in a way that allows them to move across chains in a seamless and highly reliable way that's easy to continue to operate. And this is one of the big problems that I think is an unseen, not fully understood problem, but is one of the key infrastructure decisions and principal design choices that I feel the Chainlink community has made. Now, your third set of problems, beyond data and connectivity, allowing data and value to move across many chains, both liquidity purposes and for the purposes of making sure the data is still there, is going to be the synchronization of all of this data and all of this activity with the existing system, with the existing bank backends, with the existing insurance company backends, with the existing central banks, with the existing CSDs, with the existing country exchanges, with all of the existing systems that currently manage risk, do accounting, approve, deny, evaluate, all kinds of activities for financial products and financial services. This is, I think, critical to the future of our industry, because if you look at how technology is treated within banks, it is really an onion. It is layer upon layer of technology. It is not about replacing technology. It is about layering it. And so CCIP and the various set of Chainlink protocols around data are a global standard that allows all of this data connectivity, cross-chain connectivity, AI connectivity, additional computation to do critical tasks outside of a chain to be fed into and interact with existing systems. So our approach the Chainlink community's approach to interacting with the existing financial system, existing software, existing standards like Swift, is to be compatible. Compatibility is the key aspect of our approach that I think will allow the industry to grow more rapidly. Because if you can allow the risk management department, the accounting department, the treasury department, all of the different departments to use their existing infrastructure to effectively interface with blockchains with a minimal cost, then you achieve a much greater amount of value and a much greater amount of flexibility for how those systems can now use blockchains. And that's what we all fundamentally want. We all fundamentally want to transition to a world powered by blockchains, smart contracts, and these more reliable ways of transacting. And the existing systems do have a role to play here, just like they have a role to play with the internet, because they can be made compatible. And that compatibility is one of the key aspects of what the Chainlink community and what the Chainlink set of protocols has done, is it's allowed that compatibility to exist so that you can maintain your current systems and the value on those systems can flow into various public and private chains. And then all of that value across various public and private chains can be connected. And then all of that connected value can also have the data about the value moving together with the value, which is a very critical aspect of getting the additional benefit of blockchains and the creation of these real-world asset unified golden records. Good examples of this that are live on production are, for example, our work with Fidelity and Signum, where we've already now live on production started to put NAV data on chain for tokenized funds. Tokenized funds, I would say, is the fastest moving, biggest category of RWA growth that I personally see and am excited about. And today on production, Chainlink, from what I can tell of all the analysis we've done, is the most widely used source of feeding data into live production tokenized funds for things like NAV. And so Chainlink has now emerged as the standard for both the capital markets world and is already and has been the standard in the DeFi world for many years as the set of protocols powering the majority of DeFi. So now we're in a world where large institutional players like Fidelity are going on production. This is the big shift. This is the inflection point that I was talking about, that our industry is not going to be just about cryptocurrencies made on public chains. It's going to be about all kinds of assets on public chains and private chains that are made by both startups and the largest financial institutions in the world. This is really what's happening now. The DTCC pilot that we did recently also around the NAV data is also quite interesting. It highlights the need for the cross-chain compatibility of data so that data doesn't just stay on one chain, but that it successfully operates and flows across many chains. And I recommend that you look at that pilot as something that is truly quite innovative and shows the importance of critical pieces of data going on chain in a way that can be compatible with moving across chains. The next big category of work that we're doing in the current financial markets, also live on production, is the ability to prove things about the underlying assets. These underlying assets sometimes are on-chain, sometimes are off-chain, and proving this through a system called proof of reserves is really quite critical to giving people a greater degree of assurance. So this is a screenshot of a live public chain product that proves what is inside of an ETF. And as the value inside of an ETF changes, as those assets are bought and sold, as the amount of value in the ETF grows, the underlying assets are constantly monitored, constantly proven to be there, and proven to be there at a much faster rate and at a much greater clarity and rate of granular fidelity than you would get from an annual audit, right? An annual audit gives you a year to do something weird. This arguably verifies this every day, and really, if there is a deviation threshold, then it verifies it on an ongoing basis, second by second, because if there's a sufficient change, it'll detect it. And so proof of reserves are really another key category where I see large financial institutional players utilizing it to prove things about their financial products that they don't traditionally prove in the traditional financial system, but they can effectively prove in the blockchain world. And so you're not only getting a faster, cheaper financial product because of better infrastructure like the Chainlink set of protocols, you're getting a fundamentally better asset because that asset proves things to you, manages risk better, makes sure counterparty risk exists at a much, much lower rate. And that rate is not 2 times lower. It's 10 or 1,000 times lower. So it is that type of improvement. It's 1,000x improvement. It's not a 1% or a 10%. It's one of these monumental shifts in how risk is managed, in how data is transmitted, in how value is secured, and how efficiency works. It is a 10x, 100x, 1000x type of improvement, depending on the use case. Other examples of our work with the larger financial industry that is convincing me that we are at a key inflection point is our pilot work with ANZ, a large Australian bank, where we were actually able to do a DVP, a delivery versus payment transaction against a carbon credit asset. And we were able to do that using the programmable token transfer features of CCIP. So the blockchain industry for many years has had various promises about guaranteeing programmable money. And guaranteeing programmable money has been something that has not been delivered on, in my opinion. With programmable token transfers within CCIP, programmable money is now possible because you can actually inject a set of instructions around a piece of value and guarantee that that piece of value will execute something on chain. And you can do it in a way that doesn't require you to learn the other chain. So programmable token transfers is what we use for ANZ, and we did a lot of progress and made some really great strides in proving that feature's extreme usefulness for the traditional financial markets. Our work with Swift is pretty well known, and I think is used to show just how compatible the blockchain world can be with the existing traditional financial markets world. And this compatibility is, once again, I think, the linchpin for large-scale adoption of our industry. Because, once again, banks, insurance companies, asset managers, I do not think will adopt wholly new technology. I think what they will do is they will find a way to create compatibility between their existing stack, their existing technology investment, and the next stage. This is what APIs were, right? APIs in many cases have been built on their existing technology stack. And now Oracle Networks, CCIP, the blockchain abstraction layer of CCIP is being built on top of that layer. So this is the key work that we've done with Swift to prove that existing standards like Swift messages can be successfully used to trigger transactions around many different events on blockchains. Those transactions and events can be across chains, and all of that activity can be synchronized back into the existing system. Our goal, and I think really the whole industry's goal, should be to get the whole world on a single internet of contracts made up of many different chain technologies with many great use cases from both DeFis, fintechs, and the TradFi community, the traditional institutional community, and to unify that into a single internet of contracts. Today, that is hard to do because you have a lack of legal clarity between these two worlds. The Web3 DeFi world and the TradFi institutional world are still pretty separate, but you're starting to see that barrier break down through the work I've just showed you by great institutions like Fidelity and others. I'm sure many of you have heard of the BlackRock work where BUIDL was put on a public chain. So this barrier is starting to come down very gradually. And once it comes down, what you'll have is a single global internet of contracts where everything is interconnected across DeFi startups, traditional fintechs, and traditional TradFi institutional players. And it'd be just like the internet. The internet is interconnected through a set of protocols like TCP/IP, and in the internet of contracts, we are working towards that being interconnected over CCIP, which is the cross-chain interoperability protocol, and for that to be interconnected in a way where value and data can be tightly coupled, can be highly connected so that everyone can manage risk, everyone can understand what's going on, and the value and data can move together across all of these different chains. I think this is a very exciting world we're going towards. I'm seeing a lot of great progress towards this from various central banks, really great groups in your country, and I think there's a lot of great innovation that's going on today. Once again, I feel we're at an inflection point, and I feel once we go past that inflection point, our industry will be redefined to not only be about cryptocurrencies, but to be about cryptocurrencies, real-world assets, and all kinds of institutional activity, which will mix with DeFi to create this global internet of contracts. So thank you very much for your attention. I'm very excited to be working on this with many of you and hoping to see many of you in person sometime soon. So thank you very much.